engineer at the Urban School of San Francisco. I had a student find project. My project, my goal was to levitate this disc of aluminum using permanent magnets, and I attached to a motor spinning really fast. It's the same idea that they're using for the Hendo hoverboard. I don't know if you've seen the videos, it's pretty cool. You can see Tony Hawk riding it. It actually works. So how it works, though, is probably the most important part. When the magnets spin, they are in an alternating array, so they alternate north-south. So when you spin them, you generate a changing magnetic field. And Lenz's law tells us, Lenz's law is this crazy law of electromagnetism, tells us that when you have a conductive but not magnetic piece of metal, like aluminum, in a changing magnetic field, it generates an opposing magnetic field, which means that the aluminum is going to be propelled away from the disk of magnets, which is pretty cool, and it actually did end up working, which was awesome, because I had a lot of problems, a lot of challenges. I had to use an Arduino and a potentiometer to control the speed of the motor, and I really had no experience with code coming into this project. I ran into a lot of problems dealing with the weight of the magnets, because I also didn't know anything about how torque worked, or that. Probably the biggest challenge I had was that when I came into this project, I understood the setup, I understood how the changing magnetic field and the aluminum works, but I hadn't thought about anything else. I hadn't thought about this whole safety setup. It's pretty important. We've had magnets go flying. And I think Bootcamp really helped me with that. They helped me kind of think through parts of my project that I hadn't. I didn't really have to think about them in like weeks 1 and 2, but then weeks 3, 4, 5, it really caught up to me when I had to order all these parts and took time. But it works. I'll show you.
We normally clamp it down, but
because RPM and torque have an inverse relationship. So the speed of the motor, as it tries to increase, the torque of the motor decreases. So it ends up not running as fast. That is the reason. There we go.
So what would you want to do in the future with this project?
Well, my original goal, which I would really like to see accomplished, was to make it so the motor could actually be above the magnet, that the motor could support its own weight with the repulsive force. Okay. But we can try this now. Let's come that way.
Alright, talk to the rest and what you do.
Yeah, I'll do a demo later once I figure this out. Do you guys have any questions?
Wait, so is this supposed to like float in the air, or what?
Yeah, it just hovers like about a centimeter above the spinning disc. Yeah.
So you're saying you want to have the motor on so that you have an aluminum track and then have a production
Yeah,
output?
have some kind of aluminum or copper base that the motor could float on, or a group of motors.
Why aluminum and copper?
It has to be a metal that is conductive, like aluminum or copper, but not magnetic. Because if it's magnetic, then the magnetic force is going to outweigh the repulsive force. So it's just going to get attracted straight to the disc.
So how does this apply in the real world? Like, is it related to like floating trains on tracks that are magnetic?
I mean, kind of. It's like the same principles of electromagnetism. Probably the most direct application would be the hoverboard that they've actually built. It can support a human. Pretty big deal. And they're looking at a bunch of other applications too, but that's the most